x, y, and z are all positive real numbers. And can we show that xy over z plus yz over x plus zx over y is greater than twice of the cubic root of x cubed plus y cubed plus z cubed? So natural thought is that we want to get rid of the cubic root here. And during the process, I'll be using AM-GM inequality multiple times. But we cannot use it straight away, right? It cannot be that straightforward. And it won't be very helpful either. So our desired inequality is equivalent to, like I said, cube both sides. xy over z plus yz over x plus zx over y cube is greater than 8 times x cubed plus y cubed plus z cubed. And here the left-hand side is equal to applying standard binomial expansion. First, let's group the first two terms. Then apply the formula. Of course, we have xy over z plus yz over x altogether cube plus 3 times xy over z plus yz over x square times zx over y plus 3 times xy over z plus yz over x times z square x square over y square plus z cube x cube over y cube. Right, that's the entire left-hand side. Again, applying binomial expansion. That is equal to x cube y cube over z cube plus 3 times this square times this. We can simplify right now. Right, 3 times this square, x square, cancel, simplified with this x. You only have one x at the top. And when you square y, and here is 1y, so y cube. And remember, you cube z, but simplify with this z, so we only have one z at the bottom. All right, there's no more x down here, right? So this is all good. And plus 3 times this square, right? This square, x squared, simplify with this x, right? Y squared times y cube. Z squared, simplify with this z. So no more z down here, so only one z up here. Okay. Plus y cube, z cube over x cube. All right, that's the first term. And expand this one. All right, perfect square. X squared, y squared over z squared. Plus 2 times this times that, so x simplified, z simplified. So y squared plus y squared, z squared over x squared multiplied by zx over y. Okay, so plus 3 times, so expand this one. 3 times. Now we have y. Zx cubed plus 3 times y x z cube. Copy down this term. Y cube. Okay, that's what we have. So again, we simply expand this again. So multiply this over here. What do we have? 3 times. So 3 times 2 becomes 6. 3 times becomes 3. Okay, so distribute this to here. So z, y, x cube here, right? Distribute this to here. Y, 6x, y, z. Right? 6x, y, z. Distribute this to this term, right? X, y. Z cube. Right? So this gone. Right? That's what we have in here. So just gonna look at this and group. Let me see, group this. Forget about this cube term, and right now focus on these 2 terms. Forget about 6x, y, z. And then we focus on these 2 terms and these 2 terms. So, first of all, these 2 terms, right, applying the AM-GM inequality, right, greater than or equal to twice of square root of product of those 2. Right, 3 times 3, 9. Square root of that, 3. 2 times 3, 6. Right, so this x cancel out, z cancel out, y to 6. Square root that, so y cube. Right. And now, like I said, the 3 times. So this term with this term, right, greater than or equal to, like I said, for the same reason, 6, y cancel, z cancel, x cube. Likewise, this term and this term, right? They greater than 6 times y cancel, x cancel, only left with z, so z cube. Right? Then we'll say right, so altogether, so this whole thing greater than or equal to, I'm just going to rewrite, I'm just going to copy down this term, likewise this term, because they're quite similar. So y cube, z cube, x cube, and that term over there. So z cube, x cube, y cube. Copy down this term, 6xyz. Right. X cube plus y cube plus z cube. All right. So that's what the left-hand side is greater than or equal to this. So we have to show that the left-hand side is greater than this. And now we've already just loosened the inequality a little bit, right? Since the left-hand side is greater than equal to this. If we can show that this whole thing is greater than the right-hand side, right? Because transitivity, right? Then of course, we can show that this inequality is true. So, in other words, can we show that this whole thing is greater than this thing, right? So, in other words, because remember, this is 6 times of this thing. That's 8 times of the same thing. All right, so when you subtract this from there, all right, can we show this is greater than twice of that? All right, as long as we can show that this over z cubed plus y cubed z cubed over x cubed plus z cubed x cubed over y cubed plus 6 xyz, is it greater than twice of x cubed plus y cubed plus z cubed? If we can show that, then we're done. So it all comes down to showing that this inequality is true, right? If we can do that, then we're done. Our desired inequality, right, can be proven. So which means all we have to show is that this minus this is greater than 0. Right? So here we construct a function of 3 variables. So f, in other words, can we show that f of, here I just call this f of x, y, z, right? So is it greater than 0 always, right? Given that they are all 3 variables are positive, right? And then furthermore, can we show at the same time, because this is a crucial step, can we show at the same time, first of all, f of replacing x with y, right? Whenever you have x, you replace it with y. F of y, z, is greater than equal to 0. And at the same time, if we can show f of x, y, z is greater than f of y, z, that's the crucial step. If we can show that, we're done. The reason is because if this is true, right, this is bigger than that, and this is bigger than 0, so that this is bigger than 0, right? Bigger than 0. Right, that's our desired inequality. So first of all, I'll prove this inequality, right? Because it's almost impossible for us to show this inequality directly. So I'm using this as a bridge, as an intermediate. Right. So first of all, what is f, y, y, z? Right. F of y, y, z, right, simply replace x with y whenever there is x. Right. So here we have y to the 6 over z cubed plus y cubed, z cubed, right? Y cubed over y cubed, another z cubed, right? Plus 6 y squared times z, right? Minus 2, right? Why is it twice of y cubed plus z cubed? Right. So when you replace x with y everywhere. So what is, like I said, I want to show f of x, y, z is greater than f, y, y, z. So this minus there, f, y, z, is it greater than equal to 0, right? Like I said, f x, y is this. F, y, z is that. Right? So when you subtract, I'd like to subtract correspondingly to their original terms, right? In their original position. So this minus that, see what happens. So x cubed, y cubed over z cubed minus y to the 6 z cubed plus y cube z cube or x cube minus this z cube plus z cube x cube over y cube minus another z cube, right? That's the correspondingly their first three terms, right? Corresponding position, subtraction. So after I've done that, I'd like to continue with this position, this term, and this term, right? 6 x, y, z minus y, z. So there's common factor, y, z. Right? I have x minus y. Right? Then the following the corresponding position, so this term minus this term. Minus, right, 2. Right? Then you have to change the signs of those terms. Right? So z cube gone. X cube still there. Except when you have this minus this term, so minus y cube. So we've reached the difference between fxyz and fyz, right? Remember, we have to show this is greater than that. So their difference, can we show it's greater than 0? Right? So like I said, the reason I minus in this way, subtracting this way, is because now I can extract, for example, here we observe, here we have common factor y cube over z cube, y cube over z, right? We extract y cube over z cube. Okay, we have x cube minus, what do we have left? Y cube, right? Likewise, here we extract z cube over x cube. Here we don't have x cube, so we just say z cube over x cube. We're left with y cube minus. We have to multiply this term by x cube. Right? Then z cube is extracted out, so x cube, right? Still the same thing, right? This time z equal to z cube, still the same thing. So this term, with common factor we have x cube, no, z cube over y cube, right? Here we have x cube minus, like I said, multiply this term by y cube, right? Still the same thing, right? This time that equal z cube. Right, this thing, 6yz. So here we don't have, right, so the point is that I want to take advantage of this common factor, x cube minus y cube, x cube minus y cube. Of course, here we have to change the sign later. So just so this term, right, it doesn't have x cube minus y cube. What do? We multiply, then we divide, right? So we multiply, right? Then we divide. We copy down x minus y, right? Divide. But here we apply the difference of cube, right? It equals x minus y times x cubed plus xy plus y cubed, y squared. Right, that's according to the formula. So x minus y gone. We have this, right? This is what we have for this term, right? And copy down this term, minus 2x cubed minus y cubed. So now we have a common factor. Right? We immediately factor it out. X cubed minus y cubed. Here we have what? Right, this, of course, remember, this is different sign. We have to change the sign here, but just so we keep this term and this term, right? Those two terms. Y cubed over z cubed plus z cubed over y cubed. Right, they're reciprocal. And we minus this term, remember. We minus. And we copy down this term, right? 6yz. times this, and minus 2. So I'd like to minus 2 just over here. Right? Then we'll, like I said, right, we're done with this term, and I'm not done with this term. This term will have to be minus. This term is plus. Okay, plus. So we first plus 6yz over x squared plus xy plus y squared. I'm done with this, and we minus this term. Z cubed over x cubed. Yep. So here, without loss of generality, I think we can assume that we can assume that x is greater than y, y is greater than z. Right? The reason is because if you observe closely, right, this inequality, right, I maybe move this over there, but it doesn't matter. So this inequality, I claim it is a symmetric inequality. Right, first of all, it's cyclic. Right, when you rotate x, y, z, but it's even better than that. It's symmetric. That means whenever you exchange x, y, y, z, zx, doesn't matter. Right? I'm not going to validate that, but it's really easy to verify that. It's symmetric, right? Symmetric polynomial, or symmetric function, right? Exchange xy, 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 xy. It will be the same, right? Y, z, right? Doesn't matter, right? Exchange x, z, doesn't matter, right? So we can assume that x greater than y, y greater than z. So that means this x cubed minus y cubed is already positive, right? Non-negative. Now, look at this. Right? This is right, applying AM-GM inequality, obviously greater than or equal to 2. Right? So minus 2, of course, greater than or equal to 0. Right, what about those two terms? Right. Of course. So like this, right? So this is already greater than or equal to, this blue thing is greater than or equal to, if I replace y with x, right? This time I want to loosen it. I want to make it smaller. So how do I make it smaller, right? The whole fraction is positive, right? If I want to make it smaller, all I have to do is to make the bottom bigger. Right? I replace y with x, it becomes bigger, right? So the whole thing can be greater than or equal to 6yz x squared plus x times x plus x squared. So 3 times x squared. Right? Then I copy down this. Z cubed, x cubed. Now, okay, so here's we common factor, find the common denominator. So 3 and 6 simplified down to 2. Right? So here we have x cubed. On the top, what do we have? So 2 xyz minus z squared. Okay. So immediately we realize that, right? So xyz is a third degree term, right? So is this term. So obviously, which one's bigger? Obviously, I say this one's bigger. It's because x is already big, y is already big. Right? You replace xy with z. right? This is already greater than equal to 2 times z times z times 2z cube minus z cube. Of course, greater than 0. Right. So what do we have here? All right, so finally we have the difference fxy minus fyyz, right, equals this, equals this, equals this, greater than this, greater than this. Right, so this is greater than or equal to 0. This is greater than or equal to 0. This is greater than or equal to 0. Right? So this is really greater than or equal to 0. So far we've shown that this part is true. Right? So then all we have to show is this part. Right? fyyz. Since I've already erased everything, so I'm just going to do it again. fyyz is equal again to replace x with y whenever there is x, wherever there is x. So we have y to the 6 over z cube plus x now becomes y. So we have z cube, right? X becomes y. We have another z cube, so twice of z cube plus 6 times y squared z minus 2 times x becomes y, so 2 times y cubed plus z cubed. Right, so immediately y to the 6 over z cube twice of z cube minus twice of z cube cancel, and copy this down. 6 y squared z minus 4 y cube. Right? Z cube is cancelled. Right? That's all we have. So immediately we cannot tell if this thing is greater than 0. Right? If you loosen it a little bit, how can you loosen? You replace y with z, make it smaller. Right? It becomes z cube plus 6z cube, 7z cube minus 4y cube. Right? It won't tell you much. You cannot definitively say if it's greater than 0. So instead, can we think about applying the GM inequality here? Right, so instead, so try those two terms. Greater than twice of square root of this times that. But when you multiply those, right, you're going to still have y squared at the bottom. Right, so we don't want that. So what do? Right, we say, okay, this can be written into y to the 6 over z cube. If we can break this one down into 2 times y squared z, 2 times y squared z times 2 times y squared z. Copy this one down. So this trick can help us to get rid of the z's. Right? We have 1, 2, 3, 4 terms here. Right? We can now apply the GM inequality. Greater than or equal to 4 times the 4th root of their product. Right? This time when you multiply them together, you immediately see, so this z cube can cancel with this z times z times z. They can cancel. Right? You're left with, so what? 2 times 2 times 2, 8. Right, here you have y squared, y squared, y squared, y to the 6 times y to the 6, y to the 12. Right? That's what you have here. Minus 4y cubed. And that is equal to 4 times 2, 8. No. 4 times the fourth root of 8 times y cubed minus 4 times y cubed. Of course, 4 times, so fourth root of 8 is already greater than 1, right? 4 minus, this time minus 4 is greater than 0. So y cubed, common factor, of course, greater than 0. Right, strictly greater than 0. So no matter, even if those 4 terms equal to each other, you still have, right, this strictly bigger than 0. Right, so this is really true, right? Strictly greater than 0. Right. Like I said, we've shown that fxyz is greater than fyyz. And we've just shown fyyz is greater than 0. So immediately, so transitivity, so fxy is greater than 0, strictly. Right, like I said, this is our fxyz. This time is really greater than 0, strictly. Right, so our desired inequality is really true.